Here's a problem we have. It says the height of two similar triangles are in the ratio of 2 to 5. So we have this triangle whose height is basically 2 to that ratio, or excuse me, to that triangle of 5. Now, since they're similar, the thing I know, if this ratio is 2 to 5, I know everything's been decreased or increased, shrunk down or expanded at the same rate. So if that's 2 to 5, I know the ratio of the sides, in this case the base, is 2 to 5 also. Now it says if the area of the larger triangle here is 400 square feet, so this guy's 400 square feet. That's its area. Now remember, area is always like a length times a width, or in this case, 1/2 times the base times the height. Notice that what's going to happen is we're going to have this and another ratio of 2 to 5 multiplied twice. So since this guy's ratio of its height is 2 to 5, when I do area, you're going to get a 2 times 2 here, which is going to create an area ratio of 4. This would be 5 times a 5. Basically, each one of those guys, since they're similar, and it's messing also with the bases being of a ratio 2 to 5, the area is going to be of a ratio 4 to 25. So I know the ratio of the areas is 4 to 25. Now if you're going in any shape and you're messing with the area and you're going to mess with both the length and the width, or in this case the height and the base, you're going to have to square each of those numbers. If the ratio was 1 to 3, the area would become of ratio 1 to 9. You'd have to square each one of those numbers if you're dealing with area. If you're dealing with volume, let's say we had this problem we were dealing with volume, you would have to come in and cube that number. The ratio of the volume will be 8 to 5 times 5 times 5, 125. That's something they expect you to know, to be able to mess with areas and volumes. So in our situation, the ratio is 2 to 5 with the height, so the area is going to be of a ratio of 4 to 25. Now if I set that up, I can say the ratio is 4 to the larger guy's 25. It's asking me, hey, the larger guy has an area of 400. So if I put 400 here, it's saying, can you figure out the area of the smaller triangle? Because their areas are of the ratio 4, basically 4 square inches for every 25 square inches of the big guy. So how many square inches of the small one to the 400 square inches of the larger one? I cross multiply here. I'm going to get 25x equals 1600. 4 times 400, 25 times x. We cross multiply when we have an equal sign there. We have this proportion. I now simply divide by 25. X is going to go into that number right there. Now you'll grab a calculator. I'm simply going to think of like 16 quarters. And if I have 16 quarters, that's going to give me 16 quarters, doing it 4, it's going to give me 64 there. So I know that 1600 divided by 25 is 64. The smaller triangle is going to have an area of 64 square feet is what it's going to end up happening there. So, very difficult problem, but you need to remember that when you mess with everything in a shape and you're dealing with area, you're going to have to square each of these numbers to figure out the ratio of the areas. And you would cube them if you're dealing with something that had to deal with volume.